So this lesson, this first part of the week, is going to be really short, simply because I know it's a holiday week and I don't want to slam you guys with too much. So we're simply going to talk about one aspect of factoring, because in special circumstances, we can use something called the difference of squares. And it's really factoring at its basis, most basic form. And what it says is if I have a perfect square minus another perfect square, it can break down a certain way every single time. So, for example, if I have x squared, which is a perfect square, x times x, minus 4, which is a perfect square, 2 times 2, I can take the square root of this, which is x, and the square root of this, which is 2, right? 2 times 2 equals 4, x times x equals x squared. And I can break up my factors to be x plus 2 times x minus 2. This will work absolutely every time that you have a perfect square minus another perfect square. It will not work if they're being added. It only works when they're being subtracted. It's a difference of squares, which indicates we're talking about subtraction. So it will work with any two perfect squares. So if I have x squared minus 81, well, I know that this is x times x and this is 9 times 9. So I can go ahead and write this as x minus 9 times x plus 9. Doesn't matter which order I put them in. I just know that one is negative and one is positive. They do get more complex than that, right? There are circumstances where you're going to have multiple variables, or you'll have another number in front of the x, a new coefficient. Say we have, let's look at 9x squared minus 25y squared. These are still perfect squares. 9 is 3 times 3. X squared is x times x, right? This would be 3 times 3. This would be x times x. Here we have 25. That's a perfect square. That's 5 times 5. And we've got our y squared, which is y times y. It will still work the same way if we have a perfect square minus another perfect square. I would just write these factors as 3x plus 5y times 3x minus 5y. No matter how complex it gets, it's always going to have the same result. You're going to have the square root of the first side plus the square root of the second times the square root of the first side minus the square root of the second. Let's take it even more complex. Let's get crazy a little bit here and talk about, let's change colors too. I'm getting tired of this blue, even though blue's my favorite color. What if I have something along the lines of m squared n squared minus 49? Everything here is a square, right? Anytime you have an even number as a power, you're looking in terms of a square, right? N squared is n times n, right? This is m times m. This is n times n. 49, just 7 times 7, right? So I can rewrite this as mn plus 7 times mn minus 7. So again, we're taking the square root of each piece and we're setting them up as factors. What if I've got something crazier like making it seem like I'm just making them up, but I'm not actually written down here. 72x to the 6th minus 2y to the square. When I look at this, at first, I don't see a difference of squares. I know 2 isn't a perfect square. I know that 72 isn't a perfect square, but I do see that each of these are divisible by 2. So we're going to factor out that greatest common factor between them like we've been doing and see what we get after that. So they each have a 2, right? This is divisible by 2. This is divisible by 2. So if I pull that 2 out, I will get 36x to the 6th minus y squared. Now, when I look at this problem, I go, okay, well, this is 6 times 6. This is x to the 3rd times x to the 3rd. And this is y times y. So now I can do it. Now I can factor it out, right? Because this is 6. This is x to the 3rd power, right? X to the 3rd times x to the 3rd equals x to the 6th. And this is y squared, right? So these will be my new factors. This is how I'll play my new factors. I will go 2 times 6x cubed minus y times 6x cubed plus y, right? And that's about as confounded and crazy as it can get. But we'll do another confounded and crazy example just so that I know that you're seeing everything before I send you off to do your delta math, right? What if we have two a squared b minus 32 a to the 4th b. At first inspection, we look at this and we go, well, is that a difference of 2 squares? Like the b isn't squared, 2's not a perfect square, 32's not a perfect square. But as we learned when we were factoring, we still have to pull out the greatest common factor and see what we're left with. And I know that 2 and 32 are both divisible by 2. So I'm going to start with that. Also, what they have in common is a squared, right? Each of them have a component that is a squared, right? So I'm going to pull out that a squared as well. They each also have a b in common, so we can pull out a b. This is our greatest common factor. And when I factor out 2a squared b from here, I'm just left with 1, right? Here, when I factor out 2, I get 16. If I take out 2 a's, I'm left with 2 here, so I still have a squared, and we've factored out the b. So now I'm left with 2a squared b, which is just a multiple, right? We're going to leave that alone because that's not factorable, times 1 minus 16a squared. Well, 1 is just 1 times 1. 16 is 4 times 4, and a squared is a times a. So we can create these factors as 1 minus 4a times 1 plus 4a. That is the most complex difference of squares problem that I can give you. So if you can follow along with this, you should be pretty well set in the assignment. The ones in Delta Math really, they don't get this extreme, but you will have some that look a little bit more like this. Definitely some in this respect, and for sure these top 2 versions. So hopefully you get your problem right, your Edpuzzle problem right, and you can move on. Delta Math is just 10 problems of doing difference of squares. So good luck with that, and let me know if you need any help.